Okay, so now we're going to look at a non-dimensionalization problem where we're going to be asked to find essentially a number of pi groups for some unknown function. And for your text, this is problem 5.15. So here we're told that shear stress tau wall is going to be some unknown function, right, where it's assumed based on experiment, intuition, experience. It's going to be some function of stream velocity u, boundary layer thickness delta, local turbulence velocity u prime, right? That's a fluctuating part of our Reynolds decomposition, density rho, and local pressure gradient dp dx. And the question is, we want to rewrite this as some dimensionless function. Right? This function is dimensional, and we want to rewrite it in terms of something that's dimensionless. So we're going to do this using pi theorem. So approach going to be pi theorem. So one, how many pi groups? And two, find them. So first, for how many pi groups? Um, well, first of all, let's count the variables. Right, so we have 1, 2, 3, 4, 5, 6. Right, so 6 variables. Um, let's look at the number of primary dimensions. So we have um, a length scale here, right? So we have a length scale. We have a time in so the length scale in delta. A time shows up in velocity, and a mass is going to show up, let's say, in density, and that's it. So 3 primary or fundamental dimensions. Therefore, 6 minus 3 is equal to 3 pi groups. All right, so this we're going to be able to rewrite this entire problem in terms of really just 3 pi groups. Okay, and we're told that we're going to find these 3 pi groups using rho, u, and delta as the repeating variables. So 2, we're going to use find rho, u, and delta. So this means we're going to now find pi groups for the remaining variables, which are going to be tau wall, rho, sorry, we're going to have rho is going to be a repeating variable or a primary variable, delta, and the free stream velocity u. So we're going to find pi groups for tau wall, u prime, and dp dx. Okay, so let's consider pi group 2, or let's consider pi group 1, sorry, for tau wall. This is going to have the form of tau wall over um, rho to the a, u to the b, and delta to the c. And we have to know that the tau wall has dimensions of mass per length times squared. Density has dimensions of m L to the minus 3. It's all going to be raised to the power a. Velocity has dimensions of length per time. It's going to be raised to the power b. And delta, that's just a length. And that so we're going to have L to the power c. I'll note here that for finding these things, table 1.2 in your text is enormously helpful. It essentially lists all of these things for you, so you don't have to go through the exercise of remembering that this is a stress, so it's going to be a force per unit area, and we can find a force as a mass times an acceleration, and from that you can work out that the dimensions of this are m L to the minus 1 t to the minus 2, or I really encourage you to just look it up in that table 1.2. Okay, so from this expression, now we're going to set up some simultaneous equations for A, B, and C based on, and use that to then solve for the values of A, B, and C that allow us to make this thing non-dimensional, right? To have the same m L to the minus 1 t to the minus 2 um, in the denominator of this that we have. So let's start with m. We're going to have 1, right? That's what we're looking for from the numerator, and that's going to be equal to a. That's the only place that appears. So if we look at L, so from L, we're going to end up with minus 1 is equal to minus 3a plus b plus c. For time, we're going to have minus 2 is equal to minus b. And we can see this one is pretty easy. So we have a is equal to 1, b is equal to 2, and we're going to have minus 1 is equal to minus 3 plus 2 plus c. And so we have minus 1 plus 3 minus 2, and we get therefore c is equal to 0. And so for our first pi group here, right, we're going to have pi 1 is equal to tau wall over rho to the first power times u squared times delta to the 0, right? So pi 1 is tau wall over rho u squared. Great. So now we move on to pi 2. The general form for pi 2, so let's see what's left. So this guy became pi 1. This is going to become pi 2. And this is going to become pi 3. So pi 2 is going to involve u prime. So the general form of this is going to be u prime over rho to the a, free stream velocity, big U to the b, delta to the c. And we could go through the same steps. We could also note that this is a velocity. U prime is a velocity. The free stream velocity is also a velocity. And so since so u prime and u are both length per time, pi 2 is very easily found as u prime over u. Okay, let's just put a box around the whole thing. Great, so we now have pi 2, and now for pi 3, this is dp dx. It's going to be over rho to the a, free stream velocity u to the b, delta to the c. This thing, again, if we look at the that table of 1.2 to find the dimensions of dp dx, it doesn't actually give a pressure gradient, but it does give pressure. We know that pressure is going to be mass per length time squared, and we're taking that with an additional L to the minus 1. That's over, we just copied from above, m L to the minus 3 to the a, L t to the minus 1 to the b, and L to the c. I'm just going to rewrite this. This is m L to the minus 2 t to the minus 2 over m L to the minus 3 to the a, L t to the minus 1 to the b, and L to the c. And one thing that you'll see in these kind of repeating expressions here, or when we have you have to repeat this process of finding pi groups, is that the expressions that we derived up here, the equations we derived up here for ML and T, the right-hand side, as I've set it up here, is going to be the same in all three cases. It's just the left-hand side that's going to change. And so we can more quickly come in here and say that for mass, so on the left-hand side, we're trying to balance out 1 is equal to A, so we have the same right-hand side. For length, this one's going to be just slightly different. Instead of -1, we're going to have -2 is equal to -3A plus B plus C. And for time, again, we're going to have -2 is equal to -B. So again, the left-hand side can change. So the left-hand side, as I've set this up, is based on the numerator, but the right-hand side stays the same because the denominator is the same for all of these different pi groups in the way we set up this equation. Right? So again, we have a relatively easy solution. So A is equal to 1, B is equal to 2. And so now if we plug this in, we have -2 is equal to -3 plus 2 plus C. So -2 plus 3 minus 2. So we move all of that over to the other side. So we're going to get C is equal to -1. And therefore pi 3 is equal to dp dx divided by rho to the a, right? Rho to the first power. Looking up our definition, u, right? Free stream velocity u to the b, so u squared, and delta, the thickness of the boundary layer, raised to the -1. So we can write this out a little bit more, a little bit nicer form as pi 3 is equal to dp dx times delta over rho u squared. And so we're asked for the final solution of this problem, we're asked to put this whole thing into some functional form. We can say pi 1 is equal to some function of pi 2 comma pi 3, or our final answer, plugging in what we've solved for, tau wall over rho u squared is equal to some function, some unknown function of u prime over u, comma, dp dx times delta over rho u squared. Final starred, whatever answer that we put in the answer box. But one thing to emphasize here, it can be a little bit tedious to go through setting this whole thing up. But again, if we're following the Buckingham Pi method, and we're putting, let's say for our mass, for our primary variables, we're putting the numerator values on the left-hand side and everything from the denominator on the right-hand side. We really only have to set up that right-hand side once and then just go in and make changes to the left-hand side, depending on what we're trying to solve for. So just to hammer that home, we go through here. I said that you could go through all the work, go through all the steps, and show that pi 2 is just u prime over u. But if we try this again, so for MLT, we know that the right-hand side is going to be the same as it was for everything else. So we're going to see A, we're going to have -3A plus B plus C, and for T, we're going to have -B. And now on the left-hand side, for mass, we can see that U prime has no units of mass, has no dimensions of mass, rather. So it's going to be 0. L is going to be 1. T is going to be -1, because U, or U prime, is going to be L over T. And so therefore, we immediately see that B is equal to 1. And if we plug B is equal to 1 into here, C is equal to 0. And this recovers exactly the form that we had here. So that's just a little trick that can help you if you have to do multiple of these things in a row and save you some time. All right, thanks for watching.